friends, this is Srinivas. In previous class, we had discussed about SP hybridization. Okay, now we discussed about example of SP hybridization. Before that, we have to briefly explain SP hybridization. Okay, SP hybridization, SP Sankarikana, and its examples. So, SP hybridization formed by one s orbital, one p orbital. So two sp hybrid orbitals are formed. Okay, these two sp hybrid orbitals have equal energy and equal shape. That means s orbital have 50% and p orbital have 50% character. And shape of the sp hybridization linear shape. In Telugu, Rekya Akruti, bond angle 180 degrees. So 180 degrees means Rekya Konam. So its sp hybridization also called as diagonal or linear hybridization. So this is the sp hybridization structure. This is the sp hybridization structure. This is sp hybridization ఆకృతిలా ఉంటుంది అన్నమాట. This is also sp hybridization. This is also sp hybridization. A is a central atom. So hybridization formed or hybridization only from the central atom only. That's why A, for example, A is a central atom. sp hybridization. This is sp hybridization orbital. Two sp hybridization orbital. Between these two sp hybridization orbital, bond angle is 180 degrees. That's why these all are in the same line. That's why it is linear shape. So linear Rekha Akruti. So example for sp hybridization: CuTH2, CO2, and SO2. So we have to discuss about CuTH2. So we have to discuss about CuTH2. So we explain the hybridization structure of of C2H2 acetylene. It's called also acetylene. C2H2. It's also called acetylene. Okay. In C2H2, general structure is like that. General structure. It's a general structure like that. Okay. This is the C2H2 acetylene. Okay. Here the one double bond is there between two carbons. One double bond is there, and between hydrogen carbon one single bond is there. Between hydrogen carbon single bond, and between hydrogen carbon and carbon one double bond is there. Okay. Now we have to discuss about hybridization structure of acetylene or C2H2. Okay. Now we have to consider this structure and this structure. Both are having look like a same. Those are appear look like same. That's why we have to discuss about any one carbon. Okay. Now we have to in this structure we have to find the hybridization of this carbon or this carbon. Both are same. That's why you have to find only hybridization of one carbon only. That's why you have to find any one carbon. So what is the atomic number of carbon? Atomic number of carbon. Carbon atomic number is 6. Carbon atomic number is 6. Okay, its electronic configuration. General electronic configuration of carbon is 1s2, 2s2, 2p2. This is the general electron configuration of carbon. Okay, general electron configuration of carbon. Now we have to discuss. Now let's listen. All right. So this electron configuration we have to write clearly: 1s2, 2s2, 2px1, 2py1, 2pz1, z0. Sorry. Okay. Now this is also electron configuration of carbon. Okay, look at this this is also called ground state electron configuration. This is also called ground state electronic configuration. This electron configuration is also called ground state. Ground state electronic configuration. Okay, ground state electronic configuration. In this, here 2px orbital, 2py orbital have 2 unpaired electrons. 2px, 2py have 2 unpaired electrons. But in 2pz, here 0 electrons are there. Okay. Now the bonding capacity means the bonding capacity or valency means the bonding capacity of the atom. Here carbon valence is 4, but here how many unpaired electrons are there? Only 2 unpaired electrons in ground state. In ground state 2 unpaired electrons are there. Okay, how many unpaired electrons are there? The molecule or atom ion form that number of bonds only. సో ఇక్కడ ఆటమ్కి ఈ కార్బన్ ఆటమ్కి గ్రౌండ్ స్టేట్లో రెండే జతకూడని ఎలక్ట్రాన్స్ ఉన్నాయి. ఈ 2px1 2py1 ఇక్కడ ఒకటి ఉన్నాయి. ఈ రెండు మాత్రం. అంటే ఇప్పుడు కార్బన్ గ్రౌండ్ స్టేట్లో ఎన్ని బాండ్లు ఏర్పరచగలదు? 2 బాండ్లు మాత్రమే ఏర్పరచగలదు. కానీ కార్బన్ యొక్క వ్యాలెన్సీ ఎంత, సంయోజకత ఎంత అంటే 4. మరి సంయోజకత 4 అయినప్పుడు ఇక్కడ 4 లేదు కదా, అంటే 4 అన్పేర్ ఎలక్ట్రాన్స్, అంటే 4 జతకూడని ఎలక్ట్రాన్స్ ఉండాలి, 4 అన్పేర్ ఎలక్ట్రాన్స్ ఉండాలి. ఇట్ హ్యావ్ ఓన్లీ 2 unpaired electrons. What will happen now? In the ground state, it have 2 unpaired electrons. So every time the carbon involves in the bond formation, the 2 electrons means the 2 unpaired electrons are involving the bond formation first. ఓకే, ఎప్పుడైతే కార్బన్ బాండ్లోకి ఇన్వాల్వ్ అవుతుందో అప్పుడు ఈ 2px 2pyలో ఉన్న 2 unpaired electrons ముందు బాండ్ ఫామ్ చేస్తాయి. సో దీస్ 2 unpaired electrons are form bond. Then these 2 bonds releases some bond energy or bond enthalpy. That bond enthalpy, bond and the energy used to the 1 electron in 2ps1 2ps2. Okay, from these two electrons 1 electron excited from 2s2 to 2pz. That is, look at here, 1s2 2s1, 1 electron is excited from ground state to excited state. 1 electron is excited to 2s1 to 2pz0, అంటే 2pz0 కూడా ఏమైపోతుంది, ఇప్పుడు 2pz1 అయిపోతుంది. ఓకేనా? డ్యూ టు ద ఎగ్జైటేషన్. Why it is excited? Because of 2px and 2py. These 2 unpaired electrons are make a bond. Due to the formation of bond, it releases some energy. That energy is called bond formation energy. That is called bond enthalpy. Or bonding energy. That energy is gained by 1 electron in 2s2 orbital. Okay, 2s orbital. So 1 electron from these 2 electrons, 1 electron excited from 2s to 2pz. So that is the excited state electronic configuration. It's called excited state electronic configuration. Excited state electronic configuration. Okay, now look at here. These are 4 unpaired electrons. Here only 2 unpaired electrons, but here 4 unpaired electrons. 1 2 3 4. Now carbon form 4 bonds. That is, carbon valence is 4. Now carbon valence is 4. Okay, it means around carbon 4 bonds are there. It means carbon form 4 bonds. So it means the valency of carbon is four. Means this is the valence of carbon. It means carbon form 4 bonds. Okay, now we have discussed about acetylene, C2H2. The structure of C2H2, the hybridization structure. It means the hybridization structure. Here how many unpaired atoms are there, orbitals are there? 2s 2px 2py 2pz. Among these 4 unpaired electrons, only 2 orbitals are involving the sigma bond formation. Remaining orbitals are not involving the sigma bond. Those are involving the pi bond formation. Okay, in excited state, okay, 4 unpaired atoms are there. Among these 4 unpaired electrons, this is also involving the sigma bond, and 2s1 and 2px1 are involving the sigma bond formation. 2py1 pi bond, 2pz1 also pi bond. Okay, according to the hybridization concept, which orbitals are involving the sigma bond formation? Those are the called hybridized orbital. ఏ హైబ్రిడైజేషన్ సంకరీకరణ సిద్ధాంతం ప్రకారం ఏ ఆర్బిటల్స్ అయితే సిగ్మా బాండ్ ఫామ్ చేస్తాయో అవి మాత్రమే సంకరీకరణలో, అంటే హైబ్రిడైజేషన్లో ఇన్వాల్వ్ అవుతాయి. అంటే ఇప్పుడు 2s1 2px1 ఈ రెండు మాత్రమే సిగ్మా బాండ్ ఫామ్ చేసింది. కాబట్టి ఇప్పుడు ఈ రెండు మాత్రమే సిగ్మా బాండ్ ఫామ్ చేసిన ఈ రెండు మాత్రమే హైబ్రిడైజేషన్లో ఇన్వాల్వ్ అవుతాయి. అంటే ఇప్పుడు C2H2 అంటే ఎసిటిలిన్కి ఎన్ని బాండ్స్ వస్తాయి? 2 బాండ్స్ వస్తాయి. ఆ 2 కూడా sp సంకరీకరణ వల్ల. సో ఇక్కడ ఏమవుతుంది, ఇప్పుడు 2s ఆర్బిటల్ ప్లస్ 2p ఆర్బిటల్ ఫామ్ అవుతుంది. అంటే ఈ రెండు ఆర్బిటల్స్, అంటే ఒక s ఆర్బిటల్ ఒక p ఆర్బిటల్. ఇట్ మీన్స్ 2 sp hybridized orbitals of carbon in C2H2. Carbon in C2H2. Okay, C2H2. Okay, one carbon C2H2. Now I have to discuss about that. So here carbon is there. Here also carbon is there. Okay. Okay. Okay, now friends, here carbon and carbon here. So every carbon have two hybridized orbitals, two sp hybridized orbitals. This carbon also have sp hybridized orbital. This carbon also have sp hybridized orbital. This is also sp hybridized orbital from this carbon. This is also sp hybridized from this carbon. This is the another sp hybridized orbital. This is also another sp hybridized orbital. Okay, na? So remaining 2p by 2pz, 2p by 2pz. This is the 2py, 2py. Another 2pz orbital. This is 2pz, 2py, 2pz. Okay, 2py, 2pz orbitals. This is two more. Okay, these are sp hybridized orbital. Sp. It is also sp. It is also sp. It is also sp. Okay, these sp orbitals bond with hydrogen. Hydrogen electron configuration is 1s1. Okay, now hydrogen bond with s orbital like this. S orbital shape is spherical. Shape of s orbital is spherical. So in this hydrogen is there. Okay, 1s orbital, 1s orbital. Here also bond with another hydrogen, 1s orbital. Okay, 1s orbital sigma bond. It is also sigma bond. It is also sigma bond. Okay, so here also have another pair orbital of this carbon. This is also another pair orbital of this carbon. This is also 2pz, 2py of this 2pz, 2py. Okay, now this 2py, 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 2py and 2pz have involving in the bond formation. Lateral or sideways overlap. These are called lateral overlap and sideways overlap. Due to this lateral overlap and sideways overlap, this bond is called pi bond. This bond is called pi bond. This is sigma bond. This is also sigma bond. This is also sigma bond. Now here between carbon and carbon, one sigma bond, two pi bonds are there. These two pi bonds are not involving in the hybridization. Only these orbitals are involving in the hybridization. These orbitals only describe or denote the structure of the molecule only. Remaining orbitals are not involving the hybridization. Those are not describe the shape of the molecule also. Only sp orbitals of these carbon only explain the structure of carbon. Okay na? ఇప్పుడు ఈ రెండు sp hybridized orbital మాత్రమే, ఈ sp hybridized orbital, ఈ sp hybridized, ఈ sp hybridized orbital, ఈ sp hybridized మాత్రమే ఈ యొక్క C2H2 స్ట్రక్చర్ ని వివరిస్తాయి. ఇవన్నీ ఎలా ఉన్నాయి ఇప్పుడు చూడండి ఒకసారి. ఇవన్నీ కూడా ఒకే లైన్ లో ఉన్నాయి. అందుకని ఇక్కడ బాండ్ యాంగిల్ ఎంత ఉంటుంది ఇప్పుడు వీటికి బాండ్ యాంగిల్ ఈ sp కి ఈ sp కి ఎంత బాండ్ యాంగిల్ ఇప్పుడు ఈ రెండింటికి బాండ్ యాంగిల్ 180 degrees. So that's why it is linear. Okay now friends, this is linear shape. So simply you have to write like this. Okay, how to write this? This also have to write like this. Okay, okay friends, sorry. Like this. Here also have to change this. Sorry. This also like this. Okay, all are in the same line. All are in same line. That's why it is have linear shape. 180 degrees and linear. Okay, 180 degrees linear. Okay, friends, this is the sp hybridization in acetylene. Okay, thank you. But friends, please subscribe my channel and like చేయండి బాబు. ఇది వాళ్ళదే.